guys, fancy seeing you here. I'm Mary, the girl who loves maths. Welcome to today's lesson. In this video, I'm going to be teaching you all about solving quadratics using this nasty little formula here. Just kidding, it's actually a dream, and I'm going to show you just how amazing this little baby is. Let's take a look at our first problem. In example 1, we are going to use our quadratic formula to solve this equation here. So essentially what we're looking for are values of x that will make this expression equal to 0. I'm going to pop down our quadratic formula to make this problem easier to work through. For us to get started using this formula, we're going to assign values to a, b, and c. A is the coefficient of the quadratic term, so 2 in this case. The second coefficient, -5, is associated with b. And our constant is going to be our value for c. Let me write this out so it's a little more clear. Wherever we see an a in our formula, we'll replace it with a 2. A b will be replaced with -5 and c with -12. So let's go ahead and make those substitutions. We'll start with -b. So negative and b is -5. I'm going to pop that inside its own set of parentheses so I deal with these negatives appropriately. Plus or minus the square root of b squared, so -5 all squared, minus 4ac, minus 4 lots of a, which is 2, times c, which is -12. I'm going to put all of that over 2a, so 2 lots of 2. Let's simplify this. Negative lots of -5. Well, the negative and negative give me a positive, and I've got my 5. Plus or minus -5 squared. Well, that's just -5 times -5, which gives us +25. Now for this multiplication. The negative and the negative will give us a positive. And 4 times 2 times 12 gives us 96. All of this is over 2 lots of 2, which gives us 4. Let's simplify the square root. 25 plus 96 gives us 121. And all of that's over 4. Simplifying again, the square root of 121 is 11, because 11 times 11 is 121. So let's go ahead and make that substitution. +5 plus or minus 11, all over 4. Okay, so we're coming to the end of our problem. I'm just going to work our way over here. Because we have a positive and a negative, this tells us that we're going to have 2 different values for x. So I'm going to separate this and write 2 equations. We've got x equals +5 plus 11 on 4. And now we've got to use the negative. So x equals +5 minus 11 on 4. So I split this into 2 equations, one with +11 and one with -11. Now we need to solve for each of these equations. 5 plus 11 is 16, divided by 4 gives us 4. And over here we've got 5 minus 11, that gives us -6 on 4, which can then be broken down to give us -3 on 2. So there we go, our first example complete. This tells us if we were to substitute 4 into where the x's are in the initial equation, we would get 0 as our solution. Same goes if we were to substitute -3 on 2 into the x's of our initial equation, we would again achieve a 0. On to example 2. In this problem, we are asked to solve this equation here. So what we're looking for are the values of x that would make this expression equal to 0. Here again is our quadratic formula. To put this into action, we're going to need to assign values to a, b, and c. A is going to be equal to -1, as -1 is the coefficient of the squared term. -10 is our b value, and -8 is our constant c. Let's rewrite these. And now we'll substitute these values into our quadratic formula. -b, so negative lots of -10. Again, I use parentheses whenever I'm substituting values into a formula. We've got our plus or minus the square root of b squared, so negative 10 all squared, minus 4ac, so 4 lots of negative 1, times our c, which is negative 8. All over 2 lots of a, so 2 lots of negative 1 in this case. Let's do some simplifying. Negative lots of negative 10. The negative and negative give us a positive, and we've got our 10, so positive 10. Plus or minus the square root. Negative 10 all squared gives us positive 100. Now for this multiplication, I like to focus on signs first. The negative and negative will give me a positive, and then that positive and this negative give me a negative. Now let's focus on the numbers. 4 times 1 gives us 4, times 8 is 32. We'll put that all over 2 lots of negative 1, which is negative 2. What I'm going to do is bring this negative out now, just out to the front, as it's unconventional to have a negative sitting at the bottom of your fraction if there's just a constant as the denominator. Then what I'm going to do is simplify the square root. So we have negative 10 plus or minus the square root of 68 all over 2. Now we want to simplify this radical. 68 can be broken down into 4 lots of 17. So we'll have x equals negative 10 plus or minus the square root of 4 times 17 all over 2. Let's make a little more room and work over here. Now what we're going to do is pick up this 4 and bring it out the front of our square root sign. So the square root of 4 is 2. So we've got x equals negative 10 plus or minus 2 root 17, as that 4 was brought out the front and became a 2. We'll put that all over our 2, which has been our denominator. What you might notice here is in our numerator, we can bring out a common factor of 2. So let's go ahead and do that. We'll have negative out the front, and then we'll bring out our common factor of 2. 2 lots of 5 give us that 10, plus or minus root 17, as 2 times the root 17 gives us this term here. We'll put all of that over the 2, which is our denominator. Now what you might see is our 2's can cancel, and what we'll be left with is negative 5 plus or minus root 17. Now we can multiply that negative out, and we'll be left with negative 5. This plus or minus won't change, as we'll still end up with 1 plus and 1 minus, so I'll just leave it in that form, root 17. It's perfectly fine to leave your solution this way. It shows us that there are 2 solutions, negative 5 plus root 17, and the other solution is negative 5 minus root 17. Alternatively, you can write it out more clearly. So we can write it out as negative 5 plus root 17, and also that x can be equal to negative 5 minus root 17. So what this tells us is that if we were to substitute either one of these values in for x in our initial equation, we will end up with a 0 as our solution. So that is our final example complete. Thank you so much for watching, and as always, if pre-calculus is what you're studying, you can visit the link in the description section below and study with me. I'll see you in there. Bye.